Let's move on to another proof. We want to show that the summation of I times I factorial, I starts from 1, goes to n, is n plus 1 factorial minus 1 for all integers n more than equals to 1. Let us apply the method of proof by induction. First of all, we need to make the proof for the base case. For the base case, we use the smallest value in our domain, which is 1. We need to show that P of 1 is true. It's a simple substitution. On the left-hand side, on the right-hand side, we need to see what do we have. If they're equal to each other, then we are done with the very base case. On the left-hand side, you have the summation of I times I factorial. I starts from 1, stops at 1. And on the right-hand side, you have 1 plus 1 factorial minus 1. My left-hand side has only one term, which is 1 times 1 factorial. My right-hand side is 2 factorial minus 1. Remember that 0 factorial is 1, 1 factorial is 1, 2 factorial is 2 times 1, 3 factorial is 3 times 2 times 1, and so on. So basically, on the left-hand side, you have 1. On the right-hand side, you have 2 minus 1, which is 1 again. So left-hand side and right-hand side are equal to each other. So this base case is true. Now we're going to move on to inductive step. In the inductive hypothesis, we assume that P of k is true for any k less than equals to n, and we try to prove pk plus 1. So since pk is true, let us write it down. The property for k value says the summation of all i's multiplied by I factorial, I starts from 1, goes to k, can be written as k plus 1 factorial minus 1. Now, we try to show that the left-hand side is equal to right-hand side for k plus 1. So we have the summation of I factorial, I starts from 1, goes to k plus 1. And we want to show that this is indeed equals to. So I'm going to put a question mark on top of equality. Is equal to, instead of k, we're using k plus 1. You have another constant 1, and then factorial sign minus constant 1. Okay. On the left-hand side, I'm going to break this guy down into a smaller portion. I'm going to write the left-hand side as the summation of I starts from 1, goes to k of I times I factorial plus the last term. My last term is k plus 1 times k plus 1 factorial. This is my left-hand side. I'm going to simplify left-hand side and show that it is indeed equal to right-hand side. But bear with me. You know that pk is true. So you know that the summation of I times I factorial, I start from 1 to k, can be simplified into k plus 1 factorial minus 1. So I'm going to substitute the formula here. This becomes k plus 1 factorial minus 1, and I'm going to copy down this quantity here. K plus 1 times k plus 1 factorial. Between these two terms, I'm going to factor out k plus 1 factorial and try to simplify it as much as I can. So I have k plus 1 factorial. Open this up. I end up with 1, and between these, I end up with plus k plus 1. Remember that you have a constant -1 that goes at the end. Very good. So I get k plus 1 factorial and multiplied by k plus 2. You have a constant -1. Recall that from the properties of factorial and factorial, or in general, like a factorial. A factorial can be written as a times a minus 1 times a minus 2 times a minus 3 and so on. Let me move this guy down here so we can use this and do the substitution. Times a minus 2 times a minus 3 times a minus 4 times 2 times 1. If you have a plus 1 factorial, this is a plus 1 times a minus 1 times a minus 2 times a minus 3 times 2 times 1. So as you can see, you have similarity here. This guy, a times a minus 1 times a minus 2 and so on, is repeated here. So you can do the substitution. You can write down a plus 1 factorial as a plus 1 times a factorial. I have the same pattern. Take a look. If I write down a plus 2 factorial, this is a plus 2 times a plus 1 times a minus 1 times a minus 2 times a minus 3 times 2 times 1. Again, you see the same repetition here. This is a plus 1 factorial. A plus 1 factorial is a plus 1 times a minus 1 and so on. So you can easily do the substitution here and write down a plus 2 factorial as a plus 2 times a plus 1 factorial. This is exactly the thing that is happening here. So here you have k plus 2 factorial minus the constant 1. But take a look at your right-hand side here. On my right-hand side, I have k plus 2 factorial minus 1, which are exactly the same quantity. So we just showed that pk plus 2 is also true. So we just showed that pk plus 1 is also true. It means that we proved the property by induction.